Hello and welcome. I am Dr. Anil Joshi. Welcomes you to my series Learn Radiology with Dr. Anil Joshi. Today's topic is based on radio physics and that is also on the rectifiers and diodes. To start with are the acknowledgement and disclosures. We acknowledge with thanks from those we have got this material. This material is going on in our department from many years. We are using it for teaching purposes. There are some illustrations which we have downloaded from net, but we have confirmed that they are royalty free. With this brief disclosure and acknowledgement, we go to the topic proper. Let's get going to the rectifiers and diodes. Now what are the X-ray generators? X-ray generators deliver the electronic power to the re-energized X-ray tube and permits the selection of X-ray energy, the X-ray quantity and exposure time. Major internal component of the generator include a transformer, diode and rectifier, then filament circuit and kilovoltage and milliampere meter. We are talking brief, there are a lot of components, but these are something which we must know. What are the rectifiers? Process of changing AC to DC is called as rectification. The device which produces these changes is called rectifier. The high voltage transformer provides an alternating or AC voltage to the X-ray tubes. The simplest type of use, the simplest way to use and the simple unit which uses this is direct use of them. Now, the simplest way to use this high voltage is to hook an X-ray tube directly to the secondary windings of a step-up transformer with one step of transformer connected to the cathode, that is filament, and other to the anode. What will happen if X-ray tube is connected directly to the AC current? Now we have seen that you are connecting two tubes into the two polarities. When the cathode is negative, with response to the anode, electrons will flow at high speed from cathode to the anode and X-rays will be produced. Now you have to remember a cycle in which there are upstrokes and downstrokes. Now here what we are using are the upstrokes, but what will happen when there is a downstrokes? That is negative phase, there will not be any X-ray production. During next half of the cycle, the anode is negative and the cathode is positive. So electrons, if available, would flow from target to filament. In that way, we will be using only 50% of the electric potential. It would be highly desired. Reasons are such electrons would not produce a useful X-ray, or even if they produce, they will not be of uniform quality and they will be only of using the 50% of the cycle. Then further heat and filament and reduce the lifetime. They will just, what they will do, they will heat the filament, they will heat the tube and that will reduce the lifetime. By blocking current flow in inverse half, that is downstroke, X-ray tube changes AC to DC. So it is an effective rectifier, but it's a very costly and a very inefficient method to get it rectified. This is because only half of the electrical wave is used to produce X-rays. Waveform is called half wave rectification. Why? Only we are using half part of wave for the X-ray production. So it is half wave rectification. When X-ray tube itself serves as a rectifier, circuit is called as self-rectifier. Here we are seeing which are useful, those which are upstrokes, and which are the wasted are those which are downstroke. So what they are doing, they are producing only 50%. Efficiency is used only 50%, and what that another 50% is doing, it is just producing heat and wear and tear. So this type of X-ray tubes will not be viable or long standing. Now self-rectification, what are the disadvantages? Hot anode can emit electrons, so that will emit a noise because they will not be of adequate energy levels. Now accelerate and can destroy the filament. This is because of the inverse effect. They are used for the production of electrons, but what they will do is they will start destroying the filament. Now half of the electrical cycle will be wasted. So half of electrical energy only will be used, that is a 50% wastage of electrical energy. Now rectifiers, a device that allows current to flow in the direction but not in the other direction are the called rectifiers. So it will allow only current to flow in one direction, that is the upstrokes what we have seen in the waveform, no downstrokes. So there is no wastage of energy. Incorporated into the X-ray circuit in series with a tube. You will find them that they have to be in X-ray circuit in a series, not parallel. They have to be in series. So high voltage rectifiers can be used. They can, a vacuum tube, that is lithium diode tubes are used for this reason, or can be of solid state components. So what we have seen are the thermionic diode emission tubes, or they can be solid state. There are two types of rectifiers. They can be also called diodes. Now diode is two component device. Now cathode, anode, note symbols for the diode below. This is the diode. Why? It is allowing to flow in one direction only. It is one way. Now vacuum tube, thermionic diode tubes, they can also work as a rectifiers. Now X-ray tube is one of the example which is useful but not efficient. Now solid state semiconductors material are the ideal. They can be of the full wave or half wave rectifiers. Now junction of the P and N, that positive and negative type semiconductors can be used. Then these contain impurities with excess of the shortage of electrons. So whatever are their impurities, they will be not adequate to supply the electrons. So material is also important. Silicon is the best material. Now the types of rectifier most commonly used are packed in a cylindrical stack called as sticks, that is selenium. Here see, one way yes, other way no. Now diodes are one way street for electronic current. They allow current to flow cathode to anode. They block the current from flowing from anode to cathode, so reverse flow is not allowed. There is no heating by these negative waves and no wear and tear. The solid state rectifiers are smaller, more reliable, have a longer life. Most of them are used in a modern units, and these are of silicon rectifiers or silicon types of rectifiers. Now semiconductors, the heart of the solid state rectifier is a semiconductor, which is usually a piece of crystalline silicon. N type of semiconductor, negative, positive type of semiconductor. So we got both types of semiconductors. See here what is NP means negative and positive. Electrons are flowing from negative to positive, but cannot flow from positive to negative. This is the advantage of using the rectifiers. Now biasing semiconductor rectifier. These are the biases which can be either a forward bias or a reverse bias. Forward bias is a useful, it is preferred, and negative bias or reverse bias is something which are suppressing because it should not cause heat and damage the X-ray units or X-ray tubes. Attempting to pass current from N-type to P-type semiconductor across the barriers or junction allows current to cross barriers. So this is something which will give a positive effect and it will increase the efficiency of the units. Now reverse bias is when positive to negative flow, attempting to pass current, that is electrons from positive type to negative type semiconductor across the barrier are called reverse bias. Now junction does not allow current to cross the barriers. So reverse bias do not serve any purpose. Here we are saying N-type, P-type, then no external voltage applied, forward bias and reverse bias. First is the design, second is when power supply is applied, and you can see when the polarities are changed from negative to positive and positive to negative. So the supply can be in one direction only. The semiconductors, silicon or germanium type, do the same work. Here N is the N type of dopant, that is indium, and P are the type of dopant, that is arsenic type. Then current flows only with forward bias, that is half the AC cycle, when there is either upstroke or downstroke. Now silicon rectifiers. Silicon rectifier voltage is about 1000 to around same, which is 10 to 20 times higher than the selenium rectifiers. So here they are tolerating voltage up to 1000. You can use it for the high voltage. Now can withstand a temperature of 392. So heat is not a problem. They can be heated up to 392, but they will have same efficiency. Now half wave rectification is one form. Self rectification by the tube, we have seen X-ray tube can do rectification job, but it will be a half wave and less efficient. Now same wave form is produced by two rectifiers connected in series with X-ray tube. Only advantage is the protecting the X-ray tube from the full potentials of the inverse cycle. So that will protect X-ray tube, but whatever is its inefficiency will be same. The design is shown here of half wave rectification circuit. Positive, negative, you can get a supply in only one direction only. So here what is happening to the upper cycle is it is getting converted into effective radiation, and the lower cycle is abandoned. X-ray tube connected directly of the high voltage transformer through a diode rectifier. Now if you connect an X-ray tube directly to the transformer, see what is happening here. X-ray tube is there. The designation design is of X-ray tube, symbolic. You are seeing only 50% efficiency. Alternating voltage applies to the secondary of the high voltage transformer. Now here we are getting another in detail. Now here we have got two X-ray tubes. See what is happening in the flow of the electricity. Electricity is flowing in the same direction. First half cycle, diode closed, voltage applied to the tube and tube current results. Next, second half cycle, diodes opens, no voltage applied, no tube current is there. Now half wave rectified current, it is 60 pulses per second. Only positive half cycle of the high tension transformers are used. Now they are inefficient because they are using only 50% of cycle. The negative half cycle is wasted. This is the secondary of high voltage transformer which is supplying a current to the X-ray tube, and what we are seeing down is the lower is blocked, and the upper uphill or upstroke is converted into the X-rays. Modern X-ray generator employ full wave rectification which utilizes full potential of electric supply. Then both half of the alternating voltage are used to produce X-rays. So X-ray output per unit time is twice as large as it is with half wave rectification. Now this is the secondary of a high voltage transformer. Here you see how they are connected. Then you will know how a full wave rectification is achieved. Now whichever is coming from the upper side can get only in one direction, and whichever is coming from downside is also coming in one direction. So what we are achieving is negative phase is converted into a effective positive wave that will have a continuous X-ray output. Now for that what we are used? We are used 4 diodes. Then we are used 120 pulses per second, and exposure time What we need is half of the half wave circuit. So we have saved radiation, we have increased efficiency, we have utilized power properly, that is the AC power properly, power coming from the generator effectively used, and it is totally converted into X-ray without wasting. And here how it looks a waveform of full rectifier, full wave rectification, and this is how they are connected. Now first half cycle and second half cycle, see how they are connected. By just connecting these 4 diodes in a different way, we achieved full wave rectification. Now full wave rectification rectifiers, here is a tube, this is a circuit output, and we are seeing how the electric wave is converted into a effective, all uphills, no downhills. So that will give a fully efficient total X-ray of uniform X-ray quality, uniform kV, and by this we can achieve a full wave rectification. They are efficient. Then circuit has got 2 components, 4 diodes. That is the only thing we have made, but with that we assured was the excellent output. Now pulse radiation. Intensity only significant when voltage is near peak. This is one of a disadvantage, because whatever are at peak, they are not used effectively for the X-ray production. So intensity only significant when voltage is near peak. So otherwise it is waste, or it can produce a X-rays of low kV. They will just produce a fog, or they will be filtered in the filters in the tube, which we have seen in some other lecture. Now low voltage heat target and produces a low energy photon are therefore not effective, and they are not much useful, and most of them are absorbed by the tube, filters and the patient, as we discussed just now, and can attribute to the radiation, dose, electric wastage with any positive outcome to the X-ray output. So diagnostic approach is not, or diagnostic accuracy is not as good with half wave rectification. It is excellent with full wave rectification. So also we have seen in these, even though X-ray tube can be connected in the circuit, it can act as a diode. However, its efficiency will not be as good as that of the semiconductors, which can convert both the waves, that is the upstroke also and downstroke also, into upstroke. That is how we have seen this lecture, how the rectification is allowed. With that, I thank you for giving me your valuable time. Please visit my website for comprehensive detail. This lecture is given also in more detail, describing each and every component, its advantages, disadvantages, details of the circuit at other lecture over the website. Thank you, goodbye and take care. See you in next lecture. Take care.